We have mentioned before what is the difference between a static and instance field, similarly with a static and instance method. We will refresh now our memory by providing a few more examples, as this is a topic that can be confusing unless we pay the right amount of attention. We will compare static and non-static fields, thinking of two criteria. One is the memory location of the variable, the other is the value of the variable. When a field is declared as static, when we put the static keyword in front of the declaration, that means that we will have a single memory location to hold values for that variable, no matter how many objects we're going to create from that class. In other words, all of the objects of the class will share exactly the same value for that variable. If one object changes the value, that change will be reflected across all objects, not because each object has its own copy and the change will be propagated to each of the copies. It is because all of the objects share a single copy of that variable. There is a single memory location that all of the different objects can go and read and write to. On the other hand, with non-static fields, with instance fields, instance variables, the picture is completely different. Each of the objects has its own variable, which means that every time we create a new object of that class, we also create a new instance variable for that object, a new memory location, as many memory locations as we have objects for that class. So every object of the class will also have its own value for that particular non-static field. When we are designing a class, the non-static fields, the instance fields, are characteristics of the particular objects. For instance, we have seen the wheel class that we designed. Each of the wheel objects that we're creating will have its own diameter. Same thing with the tree class. Every tree we create from that class will have its own circumference, and so forth with any kind of example you can think of. On the other hand, the static fields, the static variables, the class variables, are shared by all of the objects of the class. Why would that be useful? For instance, we may define constants in the class. There is no reason that a constant should be different from one object to another, and also there is no reason that we should keep that same constant in different copies. There will be a single memory location, a single value. Even if that variable, that static field, changes, it may still be the case that there is no reason to have multiple copies among the objects. There is no reason for each object to have a different value for that. For example, we may be accumulating information using that variable. We may want to know how many trees have been created so far. How many tree objects have we created? This is an accumulator that gets increased every time we create a new tree object. Here is an example that will help us clarify the discussion we had about static and non-static fields. We have taken these diagrams, this example, from the Start Concurrent textbook in Java. Suppose we have a class called human, and we have declared inside that class 4 variables, 4 fields. 3 of the fields are non-static, those are instance variables. One of them is static. We have declared the population as a static variable, and we have actually initialized that variable to be about 7 billion. There is no reason that every human object should have a different value for the human population. It should be shared among them. We could have defined that population variable as a constant, but if we want our human class to be used for later generations that the population may change, it is easier to define that as just as a static variable, not as a static final, not as a constant. Each of the instance variables, of course, has its own type. The name and the date of birth are strings, the height is an integer, an int. As you see on the diagram, every time we create a new human object, it will have its own values for the instance variables and its own copies for the instance variables, the name, the date of birth, and the height. In this example, we have an Albert Einstein object and a David Bowie object. However, they will not have their own copy for the static field, for the population. Each of those human objects can go and change the population value, again if it is not declared as constant, and that change will be reflected if the other human object goes and reads that value. Why? Because it is a single memory location that carries that value, and all objects can access that.